I worked on a VR project for an industrial company that wanted a full virtual walkthrough of their construction site before they built a single wall. Sounds simple, right? Until you try running it standalone on a Meta Quest 3, no PC link, no Air link, just the headset's limited hardware trying to render thousands of objects in real time. My scene had over 7,000 individual actors, each stuffed with high poly meshes. And the result? Lag, stutter, random crashes. Every test felt like a stress test for the GPU's patience. Then I discovered how powerful custom LODs can be. By manually optimizing key meshes, I slashed polygon counts without hurting visuals, and suddenly the entire VR experience ran buttery smooth. In this video, I'll break down how I did it step by step so you can keep your Unreal Engine projects fast, stable, and ready for any device. Let's jump into Unreal Engine and create custom LODs directly inside the editor. No Blender, no Maya, just Unreal's own LOD system. First, select your mesh in the level, then in the Details panel, double-click the Static Mesh reference. This opens the Static Mesh editor where all LOD controls live. On the right side, you'll find two important sections, LOD Picker and LOD Settings. By default, the LOD mode is set to Auto. Up in the top left corner, Unreal shows live data, current LOD level, triangle count, vertices count, and screen size. These numbers are what we'll be watching. To make your own custom LODs, first enable Custom under LOD Picker, then scroll down to LOD Settings, disable Auto Compute LOD distances, and change number of LODs from 1 to however many versions you want. I'm going with 4, so we'll have LOD 0 through LOD 3. Click Apply Changes. Now Unreal creates 4 LOD slots for this mesh. LOD 0 is full quality, all 9260 triangles and 8247 vertices. Each next LOD simplifies the mesh more. The screen size value controls when each LOD appears. It's basically Unreal's way of deciding how big the object looks on your screen, not how far it is in meters. So it works the opposite of distance. A screen size of 1 means the mesh is filling a large part of your view. It's right up close. As the object gets smaller on screen, that number drops, like 0.5 or 0.3, and Unreal automatically switches to a lower detail version. It basically decides how close the object is before Unreal switches to the next level of detail. So I'll start by setting LOD 0 to 1, which means full detail when the mesh is very close. Then I'll set LOD 1 a bit lower, around 0.8, LOD 2 around 0.5, and finally LOD 3 to about 0.3 for when the object is really far away. Now watch what happens. At LOD 0, the mesh has around 9,000 triangles. Zoom out slightly. We switch to LOD 1 and you can see the triangle count drop to around 4,500. That's already cutting the mesh complexity almost in half, but the shape still looks clean and smooth. No major loss in visual quality. You can orbit around a bit here. Notice how the detail reduction is subtle but effective. Now start moving further back, slowly zooming out, and watch the transition happen in real time as Unreal shifts to the next LOD level. LOD 2 cuts it down to around 2,800 triangles. Now the mesh is getting noticeably lighter, but still holds its shape surprisingly well. Take a second to pan around. You'll see tiny surface details starting to disappear, yet the overall form is still perfectly readable from this distance. Keep pulling back slowly, and as we reach LOD 3, the count drops again. Now it's just about 1,100 triangles. That's almost a tenth of the original complexity. You might notice some smaller details fading or parts of the mesh simplifying a bit, but at this distance during gameplay, it's barely noticeable, especially when the LOD transition is tuned correctly. That's roughly an 8-fold reduction, and visually it's almost identical from a distance. Save the mesh, and this optimization will instantly apply everywhere it's used in your project. This technique is massively underrated. Most devs don't even realize they can generate custom LODs right inside Unreal without any external tools. If you fine-tune these values for your scene, you can run high detail environments even on low-tier devices with stable FPS and zero stutter. Experiment with the number of LODs and screen sizes until you hit that sweet spot between quality and performance. And if this helped you, hit like and subscribe. I've got plenty more Unreal optimization tricks coming up.